Problem 2. Electrons in a magnetic field. A beam of electrons emitted by a point source P enters the magnetic field vector B of a toroidal coil, toroid, in the direction of the lines of force. The angle of the aperture of the beam 2 by alpha 0 is assumed to be small, 2 by alpha 0 much less than 1. The injection of the electrons occurs on the mean radius r of the toroid with acceleration voltage v0. Neglect any interaction between the electrons. The magnitude of vector B, is assumed to be constant. Question 1. To guide the electron in the toroidal field, a homogeneous magnetic deflection field vector B1 is required. Calculate B1 for an electron moving on a circular orbit of radius r in the torus. Question 2. Determine the value of vector B which gives 4 focusing points separated by pi over 2 as indicated in the diagram. Note, when considering the electron paths you may disregard the curvature of the magnetic field. Question 3. The electron beam cannot stay in the toroid without a deflection field B1, but will leave it, with a systematic motion, drift, perpendicular to the plane of the toroid. Part A. Show that the radial deviation of the electrons from the injection radius is finite. Part B. Determine the direction of the drift velocity. Note, the angle of aperture of the electron beam can be neglected. Use the laws of conservation of energy and of angular momentum. Given data, charge E over mass m is 1.76 by 10 power 11 coulomb by kilogram, V0 equals 3 kilovolt, R equals 50 millimeters.